Hello class, for today we're going to be talking about tree diagrams, how we can find the probability in a given situation when it's not given to us traditional in a table setting. We're going to be talking about how to find a given conditional probability or uh, probability of this and that situation whenever we're given this type of questions like this. Okay, so let's jump right into it. This will be an example, and I'm going to show you two examples for today, and then you're going to do one example by yourselves as homework problem for today. So complete the tree diagram below showing the appropriate probabilities. Maria travels to school either by walking or by bicycle. Notice how in all of these cases you're going to get two different types of scenarios. Of course, you can have three different scenarios and that's going to give you a given probability, but what you always want to make sure you understand is that every given probability, it adds up to 1 in those particular cases. So for example, the probability that she cycles to school is 0.75. If she walks, the probability that she is late for school is 0.1. Wait a minute. I think we're getting a little bit too ahead of ourselves here. We gotta stop from this sentence alone. Okay? Oh, actually, wait a minute. The probability she cycles to school is 0.75. So what this particularly means is that you have either two options in the very beginning. So let's say that's Maria. Maria has an option to walk or cycle. If she decides to cycle, it's going to be 0.75 as a chance. But what does that leave for walking? It means that the other 25% of the time she's going to walk, because for that given situation, in that particular given situation, like I said, it has to add up to 1, okay, with that. So now, when we say 0.75, that's 75% chance that she's going to end up cycling, 25% chance she's going to end up walking. Now, given that there's no other options, whether she runs, jogs, takes a car, takes a bus, all of that is pushed aside. You either have walking or cycling situation. It's either this or that. That means if one of them is given to us 75%, the other one should be the complement. I hope you understand what complement means. Complement of the first probability, which is 1 minus the probability of whatever that is. You know, in this case, 1 minus the probability of cycle is the probability of walking. So that should give you the 25% right there. Okay, I'm just gonna move this aside, erase this. Now, let's go on to our next sentence. If she walks, the probability that she is late for school is 0.1, and if she cycles, the probability that she is late for school is 0.05. So if she walks, the probability that she is late for school, that's going to be 10% of the chance. And if she cycles, the probability that she is late for school is 0.05. So you gotta make sure you indicate each of these numbers as accordingly. I'm gonna use a different color here, and I'll show you in a second why. I'm gonna be using, let's say, blue color here. So 0.05, I believe that was the case, right? Yeah, that was 5%. Okay, so I have told you before that specifically, whatever the case is, that they have to add up to 1, and we gotta find the complement of it. Now, what I would like you to consider is this. I can't zoom in for some reason. Okay, there we go. I need you to consider this branch where we end up walking. Now, after you walk, that's given. Okay, so we have taken this path. At this stage, you're right here. How many options do you have? You have two options. Either you're going to end up being late, or you're going to end up not being late. So these two have to add up to 1. Not that all of these branches add up to 1. That's not what I'm talking about here. It's that only these two branches have to add up to 1. What that means is, if there's a 10% chance that she's going to end up being late, that means that there's going to be a 90% chance that means that it's going to be 90% chance that she's going to end up not being late. So I'm going to write 0.9 for here, because you only have those two options, and those two options have to add up to give you 100%. Then I'm going to go to the blue section, and I'm going to do the same thing. If there's a 5% chance that she's going to end up being late, what's the chance that she's not going to be late? It's going to be 0.95, and that's going to be 95% of the time. Whenever you're doing tree diagrams, guys, there's one thing that you have to keep in mind. You need to make sure label all the probabilities. That is the most important thing that you have to do for tree diagrams, because once you have everything written down here, then you can take that and then you can apply it to answer these questions, part A and part B. So complete the tree diagram below. So that is a question, and this is basically completing the diagram. What that basically means is to label all the probabilities, fill in the blanks, or just, you remember in the very beginning it was just 0.75, but now everything is just written down. All of these numbers, 0.25, 0.5, 0.9, 0.05, and 0.95, they all have to be written down to be considered completing the diagram. Find the probability that Maria is late for school. Okay, so then how do I do that? Well, first of all, there are four different outcomes. There is this branch where she takes walking and then ends up being late. She walks and then not being late. She cycles and then not becomes late. And then she cycles and then not becomes late. So there's 1, 2, 3, 4 different types of possibilities within this given tree diagrams. And whenever we're given these guys, we want to be certain. We want to find out the probability for each of those cases. And here's how I find it. So let's write all of them down. I walk, and then I become late. I walk, and then I become not late. I cycle, and then not become late. And then I cycle and not late. So there are 4 different possible cases. So how do I find out the probability for the very first one? Well, the probability that she ends up walking and that she ends up being late is 0.1. And then what am I going to do with those 2 probabilities is that I'm just going to simply multiply. Because why? It's an AND situation. This is happening after certain things are happening. You always multiply them. So when you do this, I'm just going to move this up here. So 0.25 times 0.1, if you type that in your calculator, what you're going to get is 0.025, or approximately 2.5%, or exactly, right? That same thing is translated as 2.5%. Now, the next one is that she walks, 0.25, same thing, but now she ends up being not late, which is 0.9. So what is 0.9 times 0.25? If you type that in your calculator, I believe you get 0.225, which is about 22.5%. Okay? So here, if you take a look at these 2 types of situation, if you were to add these guys up, okay, choose a different color for this one. If you were to add these guys up, you get exactly 25% as the first case scenario. Now, the last 2, cycling, she ends up 75%, but that she becomes late is 0.05. So if you type that into your calculator, what you're going to end up with is, I believe, is that it's 0.0375, or approximately, not exactly 3.75%. Okay? And then when you do 0.75 times 0.95, because that's this branch, cycling and then not walking, cycling and then not being late, that's going to end up giving you, how much would that give me? 0.7175, which is about 71.75%. And when you add these guys up, you get exactly 75%, just like the one in the original. And finally, when you add these guys up, what do you get? 100%. Like I said, no matter what you do, all of these cases should end up adding up to 100%. Then what's going to end up happening is that you are going to take a look at, find a probability that she's late for school. I don't care about cycling or walking. I care about being late. The late is here and here. That's this guy and this guy. So what I'm going to do is I'm going to take 2.5% plus 3.75%. That's the cases where she ends up being late. Doesn't matter if she walks, doesn't matter if she cycles. So that's going to end up being 6.25%, and that's going to be my final answer. Okay? All right, so that's one tree diagram. And now what I would like you guys to do, it's already like about 10 minutes here. First, what I would like you to do is I would like you to take a look at this question and then apply the same thing. So complete the tree diagram below showing the appropriate different probabilities. So I would like you to draw this tree diagram on a piece of paper and then complete the tree diagram for me. Part B, find the probability that Lisa cooks dinner. So Lisa cooks dinner, which is this one, and then do not have pasta. So what that means is if the probability of A is given here and the probability of B is given here, what you're going to do with those two is you're going to simply multiply them, right? And so forth and so forth and so forth. So part C and part D, D is the most tricky part that I would like you to really think about. Given that they do not have pasta, find the probability that Lisa cooked dinner. Remember, probability of A given B is probability of A and B over probability of B. That's the given conditional statement probability question that I would like you guys to challenge yourselves with. Part A, B, and C. Part C, I really want you guys to draw this chart out and to really demonstrate for me as to how to get this question done. I was going to go over this, but because the video is going to take such a long time if I do so, I'm going to leave this question for you guys to do as homework. This question, I'll give it to you guys to do next time. Okay, so thank you for today. Please finish up number 5, and I'll give you this on the PDF format, and that's going to be it. On Friday, we'll take a quiz on conditional probability. Tomorrow, we'll review, so don't worry about that. And thank you, and have a good day.